Okay, objective 3, we are given a polynomial equation. So instead of saying find the zeros, we're actually given an equation. So if it doesn't already start as an equal 0, you first put it into an equation with equal zeros, and then you just find the zeros just like we were doing in objective 2. So for 3a, we have x to the 4th minus 6x cubed plus 22x squared minus 30x plus 13 equals 0. So we want to find all the zeros. So first we want to note that the degree is 4, which means there are going to be 4 zeros. Now, of course, remember we talked about before with multiplicity, it doesn't mean there's 4 unique zeros, but there are going to be 4 of them. So if we first want to see what are our possible rational zeros, because we need somewhere to start, we're going to need factors of our constant, which is 13. We're going to divide that by factors of our leading coefficient, which is 1. So the factors of 13 are just 1 and 13. Factors of 1 is just 1. So we only have 2 or 4 possible factors, positive negative 1, positive negative 13. So let's start trying these. So let's start with 1. Our coefficients are 1, negative 6, 22, negative 30, and 13. And here we have a good mixture of negatives, so negatives and positives, so we might have a positive 0. So bring down the 1. 1 times 1 is 1. Negative 6 plus 1 is negative 5. We have a negative 5 here. 22 minus 5 is 17. 17 times 1 here. 17 minus 30 is a negative 13. So we have a negative 13 and 0. So on our first try, we see that 1 is indeed a 0. So the polynomial we have now is x cubed minus 5x squared plus 17x minus 13. Okay, so now we're trying to find the zeros of this. Now, again, we can check to see if we can factor by grouping, but in this case we can't, because it would be x cubed minus 5x squared, and there's no factors here that would make it all match. So we have to do this again. So possible factors, again, we have factors of our constant here, which is 13. So positive negative 1 and 13 over factors of our leading coefficient, which is again is 1. So again, we have the same possibilities of positive negative 1 and positive negative 13. But now we have a new polynomial. So we start testing again. Let's see if 1 is a repeat 0. So I can just kind of bring down these coefficients. And my 1 goes down. 1 times 1 is 1. Negative 5 plus 1 is negative 4. Negative 4 here. 17 minus 4 is 13. 13 times 1. And again, we get 0. So 1 is has a 0 twice. And what we have left is x squared minus 4x plus 13. So we need the zeros of this. Again, numbers that multiply to 13 and are going to add to negative 4 is impossible. So we are again going to have to use the quadratic formula or completing the square to solve the equation, this quadratic equals 0. So we have the opposite of b, so we have a positive 4 plus or minus the square root of our b squared, so negative 4 squared, minus 4 times a, which is 1, times c, which is 13, all over 2 times my a. Okay, so we have 4 plus or minus the square root of negative 4 squared is 16. Negative 4 times 1 times 13, so 4 times 13 is 52, so 16 minus 52 all over 2. So we have 4 plus or minus the square root of 16 minus 52, which is a negative 36 over 2. And up here we have a negative, which means we are going to have to take it out for an I. So we are going to have an I, and the square root of 36 is 6. So square root of negative 36 will be 6i. So we have 4 plus or minus 6i over 2. Now we can divide both terms by 2, and we end up getting 2 plus or minus 3i. So my zeros here. I have my 2 plus or minus 3i, so that's 2 of my zeros. And then I have a 1 that is repeated twice. So we really only have 3 zeros here, but this one has a multiplicity of 2. In my math lab, they won't really care about the multiplicity, so you just, I don't think, at least the practice you'll do today won't care about multiplicity, so you just have the 3 zeros. But note that this one does have a multiplicity of 2, which means you have found all 4. Okay, 3b. We have x cubed minus 10x plus 12 equals 0. So this degree is 3, which means you're going to have 3 zeros. Possible rational zeros. You have the factors of your constant, which is 12. So the factors of 12, we have 1, 2, 3, 4, 6, and 12. You don't have to write them in numerical order, you can write them in any order you want. So we have 1 times 12, 2 times 6, 3 times 4. And then our constant, or our leading coefficient is 1, so it's just everything over 1. So we have a lot of different possible ones, so let's check and see which ones actually go into here. So we start with positive 1, which is where I always like to start. Bringing down the coefficients, coefficient is 1. Now note we don't have an x squared term, so we do need to put a 0 in there. And then a negative 10 and a positive 12. Bringing down the 1. 1 times 1 is 1, 0 plus 1 is 1, 1 times 1 is 1. Negative 10 plus 1 is negative 9. We have a negative 9 and a 3, so 1 is not a 0. But let's check negative 1. So bringing down the 1. 1 times negative 1 is negative 1. 0 minus 1 is negative 1. Negative 1 times negative 1 is positive 1. Negative 10 plus 1 is a negative 9. This is positive 9, so this is 21. So again, negative 1 is also not a 0. Well, let's try 2. So 1, 0, negative 10, and 12. Bringing down the 1. 1 times 2 is 2. 0 plus 2 is 2. 2 times 2 is 4. Negative 10 plus 4 is negative 6. Negative 6 times 2 is a negative 12. And this does give you 0. So we do now have a 0 of 2. And the equation we have left, we have x squared plus 2x minus 6. And we're solving that for equal 0. So we need two numbers that will multiply to 6 and add to 2. So either 1 or 6 or 2 or subtract to 2, sorry. 1 to 6, subtract to a 5, and 2 to 3, subtract to a 1. So this one again is not going to factor nicely, so quadratic formula again. So my x is going to be the opposite of b, so negative 2 plus or minus the square root of b squared minus 4ac all over 2 times a. So negative 2 plus or minus the square root of 4. Negative 4 times negative 6 is a positive 24 all over 2. So negative 2 plus or minus the square root of 28 over 2. 28 is 4 times 7. So we have a negative 2 plus or minus 2 square root 7 over 2. Divide both terms by 2. We have a negative 1 plus or minus the square root of 7. So all of my zeros, I should have 3. So I have a negative 1 plus or minus square root of 7. So that's 2 of them. And then we have the 2 that we found before.